So let's continue with Ethereum. I'm sorry, Web3 Js. So if you remember, Web3 Js is a collection, or it's just an interface where you can talk to the blockchain on the blockchain. And using Infura, you can talk to any specific node and talk to the blockchain, the Ethereum blockchain. You can get data, you can create accounts, you can send and receive Ether. So yesterday we saw how we could send and receive Ether using Web3 JS. And right now what we're going to do is we're going to continue with our class yesterday. So we were trying to send a raw transaction using Web3 to the block. A bit of an advanced class. And the reason we are using we'll be using the Ethereum JS transactions library, because we don't want to download the whole blockchain in our system, which is why we'll be using, if you remember, we installed the npm Ethereum JS.transaction, which will help us to have a Ethereum, because we can't have an Ethereum node locally. We could just unlock an account that is stored locally and we can sign the transaction. Hence we'll be using Infura. So what we're going to do right now is we're going to sign a transaction, then send the transaction and broadcast the transaction to the Ethereum network. So if you remember, yesterday we created an app.js in VS Code or your code editor. Okay, so we've installed Ethereum JS transaction, which is like which will help us with any sort of transactions on the Ethereum platform itself. But since we're not downloading the whole node, we'll be using Ethereum JS, which will connect us to a node on the network. And we'll also require Web3, and we are connecting using our Infura Ropsten network. So how do you do that? You go to your Infura, you created an account, right? So you need to change it. Open up your project, go to settings and change the endpoints to Ropsten. So we will be using now some test fake ethers. So we don't want to use the real ether, we'll be using fake ethers. And you go ahead and paste it in your app.js file like this. All right, so we need to also make sure we get some fake ethers. So I'll help you in that in a second. So let's try creating an account. We need to create 2 accounts. Now what we're going to do is we're going to try and send some transaction from account 1 to account 2, and we're going to broadcast that transaction. It's basically a raw transaction. We're going to send it over to the broadcast it to the network, and it's like how any other transaction works. All right, so to create an account, you can do this. Web3 Okay. If you want to get any updates, information on Web3 tools, you can go here. Web3 documentation. You'll be able to find everything here. Okay, if you remember Web3 contracts, if you want to do anything with the accounts, you can check out the Web3 Ether accounts. Okay, so you can create accounts like this. So you got one account here. Okay, make a note of the account. If you remember in Web3 Js, if you want to create an account, it'll automatically create. You can create an account, but remember it's going to give you the private key as well. So you need to remember not to share your private key with anyone. But since this is a test network that I'll be creating, so we'll be using some fake ethers. So I'll go ahead and I'll create another account as well. So I've got my two accounts ready, and I'll go to the next part. So where is it? I paste in my account number 1 here. Okay. So after this, what I do is I need to fill these accounts with some fake ether. So what I do, I go to Austin. Once you're in the faucet, all you need to do is, if you remember in your first class, we actually got some fake ethers similar. We just go into this faucet, getting some fake ethers, some test ethers. So, pressed it too quickly. Okay. I'll try that after some time. After which, we are assigning them to some variables again, and similarly, we'll need to even assign the private keys. First of all, you need to change your private key to a binary thing, okay, which is why we'll use this buffer thing. Let me show you how. Private key 1. So you can also save it in your. So the next, what we need to do is we need to basically use this. Okay. Okay, assign a private key here. Okay. So it's not exactly a good idea to post your private keys like this, But then we can, there's always there's another method where you can assign this private key to something called as the, you can just, it's like how we did it before. So it can be something like a private key. We can assign it to this, and then, console log it to get, convert it into a binary. We're using this buffer to basically convert it into a binary. Okay, so to basically try and send some transaction, I need some fake ethers. Okay, let's do. Was anyone else able to get some fake ethers? Excuse me. Okay, from this point on, what we're going to do is we're going to basically try and build a transaction. Okay, build. Build a transaction object, and we'll sign the transaction. Broadcast. Okay. So basically, we're going to now, what we're doing is we'll be building an object that has all the values needed to generate a transaction. Okay, if you remember, any transaction in the Ethereum network, right? It needs to contain what? Anyone can give a guess? What does a transaction have? In our level 1 classes, we've learned. You remember nonce? You remember the account we're sending the ether to? Sorry.
Gas limit and gas price.
Yeah, right, exactly. So the value, the amount of ether will be sending across, and also gas limit and gas price. You're right. Okay. So let's create that. So now we're actually creating a callback function. Okay, we are wrapping all this inside a callback function. So it'll be the same thing that we did while sending a transaction. So first will be the nonce. Then you have to, and the value. Gas limit. Gas price. Nonce. We'll get to that in a bit. Okay, if you remember, it's just the number of transactions that went from one account to the other. So in Ethereum, it's just the number of transactions that, it's just to prevent the double spending. So once a transaction happens, right, it will get recorded in nonce, and anytime another transaction is, if you're trying to do the same transaction again twice, it will not happen. It will change the number, so which will give us you know it, the double spending will not be an issue here. So we're going to send it to account 2, and the value we'll just put in like 1 ether. So we can use Web3 utils for this. So I'm going to be converting way to ether. First of all, we need to convert it into an hexadecimal number. Web3 dot utils way, and the amount, it's going to be 0.1, let's see, 0.1. And ether. Gas limit, Web3 dot. Give the value of 20,000. Default will be like in way, okay? You can convert it using utils to ether or which one. Gas limit. Okay, gas price will be at 3 dot. There's another thing called G way, okay? It's, after way. Way is the smallest quantity of ether, and G way is the next. Let me get this. So I'm building the transactions. Okay, so for building the transaction, we got the nonce, and here it's just the transaction count. Okay, and he's sort of, if I send from account 1 to account 2, if I send 1 ether, it'll become transaction number 1, then it becomes 2, then it becomes 3, like that. So we use the Web3 utility to make a record of all the transaction counts. So this is basically a callback function. We are wrapping it inside this callback function, all this. Now we need to sign the transaction. Right, so to sign the transaction, we need to, it's just like, last time how we did for sending transaction now. Go to the new transaction, new. This is actually making use of the, Ethereum JS transaction library. This is going to sign a transaction using our private key. Okay, we created a new transaction object, and using our private key, we're actually going to sign the transaction. Also, next what we need to do, we need to serialize this transaction, and we need to convert it into hexadecimal as usual, hexadecimal string, so that it can be passed to Web3 JS. Right. Say const serialized action. Just giving us the transaction ID. If you remember any sort of transaction, you'll see something called as a transaction ID, right? So we're just creating a transaction ID lens. GX. Equals transaction. Okay, next we broadcast the transaction. Now, all this is all from the library. Okay, it's the Ethereum.js library. You'll be able to get some information about, or if you want to get any codes related to this, you can go to Ethereum transaction library docs. And so just installing it, but you'll be able to get be able to check out the usage here. Let's see. So require Ethereum transaction, the private key, the nonce, the gas price, gas limit, value data. This data is also not that required, but similarly, if you go to any transaction rate, you get all this. Even if you're trying to send some fake ether from MetaMask, Also, this. So use MetaMask for your information. You can always use MetaMask and the private key from there. And someone else is able to get some fake ethers. But anyway, so after this, finally, what we need to do is just broadcast that information to the network. To do that, we're just gonna send some transaction. So we're going to sign this transaction and send it across. To do that, Web3 send sign transaction. Okay. All right, so finally what we do is we say broadcast the transaction Web3 e.sign transaction raw, the transaction hash, and then we'll to run this, what you can do is you can just type in for this you also need to add this information web3.e.get transaction count. So the transaction count. All you need to do is, I don't have any ether, so it's not going to work. If you want to run this, just put node and then app.js. No, it should actually send a transaction. So if you check your transaction right in the ether scan, you'll be able to see the transaction if it went through, and also you'll be paying the gas fees, etc. So see if this works for you guys. I'm not getting fake ether, but again, I will try to getting some fake ether. So finally, our project should look like this. The app.js should look like this. It should have the requirements. We are requiring the Ethereum JS transaction Web3. Then in Fura or Opston, we got account 1 and 2, the private keys for it. Then we do the transaction. We start building the transaction, which will include all the nonce to the value, the gas limit, and the gas price. Then we sign the transaction, and then we broadcast that information to the rest of the network. You can run node app.js to transfer the ether from one account A to account B, and it should give you the you should be able to check the transaction on Etherscan. But make sure that you're sending fake ethers from using the Ropsten network. Right, Web3 should be good so far, but let me get we'll do this again once I get some fake ethers. and see if it actually, you're able to send the transaction. But if anyone else is able to do it, now, you're welcome to share your screen and see, we can check out the transaction. Was anyone able to get some fake ether from Robston? Ashwini, Dhruti, Ashwini, Manisha, Rohit, Krishna.
Yes, sir.
Were you getting some fake ethers? Dhruti?
Sir, I'm currently using my phone, sir.
Okay, right. Anyway, I'll have, I have this recorded. So what you guys can do is just see if you can send it, and we'll try sending this transaction again in the next class. So Web3 Js is good so far. What else I would like you guys to do is try this out. Apart from this, I would also try, request you to try the next lesson, which is, deploying the deploying a smart contract using Web3 Js. So that also can be done. You can even deploy your smart contract on the Web3 J on the Ethereum blockchain platform. So that's it. So data, yeah, it's just nothing but the bytecode. So it's this, if you remember the bytecode and the API. So the data, you can include data with this. You'll be able to deploy the smart contract on the blockchain. So check this out and see if you guys are, getting it. If not, you can always reach out to me and we can work this out as well. So next lesson is we'll be creating our next project, which is the to-do list. So let's start with to-do list.
So
Yeah. And this to-do list will be without
can I know why we are using
Sorry?
Can I know why we are using buffer?
Buffer.
Yes, sir.
Okay, we need to convert it into binary. Basically, there is a requirement. Okay, the private key, right? It needs to be converted into binary.
Okay.
So this particular functionality will help us converting that private key into to binary.
Okay.
So that's it.
Okay.
Yeah. So this will get converted into binary. So it's a requirement.
Okay.
Okay. You guys know how to-do list app works, right? Just like a regular one. So all you do is you create a list of to-do items and you can mark it off once it's complete. So that's what we're going to build using the truffle framework. And the dependencies required for building a project is as usual the same old stuff. You require truffle, you need Web3 Js, you need VS Code, we'll need Ganache to help us with local blockchain, and you'll need the truffle to basically compile and deploy a smart contract. So first of all, what we need to do is create a project. So you can do this by open your terminal. Okay, go to your desktop, see wherever you want. Like you can create a folder anywhere you want. Make to-do list. And what we're going to do is we're going to initialize okay, we're going to initialize a project. Okay, we'll use something called as the truffle init. So this will just give us a package.json file with some basic files. It will give us okay, just like unboxing some basic boilerplate codes only. Okay, you'll have something like let's check it out. The migration folder, you'll have the contract folder. You have a test folder as well. So here you'll see the migration, the first initial migration, and you'll have the contracts where you can insert our smart contract. We can create a solidity file here, and the test to create our test. So truffle init will just give you basic structure, just like a skeleton where you can start building on top of. Now we need to create a package.json file, okay? And we'll copy a code which will basically install all the dependencies. To do this, what we can do is create a package.json. Okay, so here we'll just put in all the dependencies that we require. For that, I'll send you this. You can go to okay, I'll share this with you guys. Some of the basic dependencies, okay, you'll need like the Mocha and Chai testing frameworks. You have some sort of front end, the Bootstrap, Light Server, and the Truffle. And to install this, what do you do? Go to terminal and just put in node. I'm sorry, npm install. Npm install all the dependencies. Okay, so okay, and then we wait. So here's where all your smart contracts will live. We now will be writing our smart contract here, the to-do list smart contract, the migration. If you remember, it's going to migrate our contracts to this, the blockchain. Then testers using the Mocha and Chai testing assertion library will be able to test our smart contract. Wait for all the dependencies to install. Okay. Next, we create what is called as the, we can create a file called solidity. So we'll be creating our solidity. On the contracts, create a file, name it list. Okay. Should I come up automatically? And this trophy configuration file, as usual, what you guys need to do is just make sure that you add in the details like network. Yeah. You can just uncomment these out. Change this to 7545 like you're gonna show. And we can start writing our smart contract here. So it's a similarly pragma solidity version and then to-do list. And we can start writing our codes. 0.5 point. Versioning is always an issue. So initially what we need to do is get the task count. Okay, it's like a special variable which will we can which will be stored on the blockchain itself. So event task count. And we'll give it initially, we'll just give it a default value as 0 because currently we have no task. So anytime we add a task, the task number will increase to 1, 2, 3 depending on the number of tasks we had. We'll create a function where we'll create a function which will help us add the tasks, and we'll also create another function once the the task is complete. It should automatically be checked. So this is a state variable which is being stored on the blockchain itself. Okay, and we want this to be publicly available outside the smart contract. So what you can do is just mention public here. So automatically give us a getter function which will be able to call outside the smart contract. So initially what you can do is you can try compiling this in the terminal, see if everything works. So truffle compile that. Yeah, I had a doubt that the package didn't install properly. We do this again. Okay, only now it's installing. So okay, just create a file outside yourself. So once you create this project, right, just create this package.json outside normally, and paste the one that I sent you. Let's see if it works. It's going to take some time. Let me pause the